those will be questions that you won't be able to use your calculator on. Any other question? Yes. Sure. Where? What do you need to see?
Right there.
Just need to see my name on that one.
No, I needed to see the last part.
Yes.
I need y'all to triangle so you know like all your angles and stuff. I'll have that shot.
All right. The triangles. 30, 60, 90. You got 2 on the hypotenuse, just like at 45, 45, 90. You got 2 on the hypotenuse there. The only difference is that 2 is going to have a square root with it. So 2 is on both hypotenuse. Both hypotenuse. I don't think that's right, but anyway. Two's there in both cases. Now, on the 30, 60, 90, you've got 1 being the short side, and the square root of 3 is the long side. And then on the 45, 45, 90, it's just 1 and 1. So from there,
you can find the sine, cosine of 30. I don't know.
Hold on, you can find the sine.
Huh?
What does that tell you?
That tells you, like, if I want to know the cosine of 60, cosine is what over what? Adjacent over hypotenuse, so it would be adjacent over hypotenuse. Now, Mr. Wilbanks, he tended to teach from the unit circle. I didn't. When I taught trig, I didn't teach from the unit circle as much. I introduced it, but I tended to teach it from that because that was just the way it worked for me to remember it best. Well,
I understood the unit circle.
okay. All right. 45, 45, 90? That would be like if you had the sine of pi over 4. The sine of pi over 4, you'd be dealing with a 45-degree angle. So it would be 1 over the square root of 2.
And the other one's for
Pi over 6.
Like pi over 6 and pi over 3 stuff.
Pi over 3 is
60 degrees.
Pi over 3 is 60 and pi over 6 is 30. Yeah.
But, okay, if you're like, have the sine of 5 pi over 4, would it be the same as the sine of pi over 4?
Except your signs would be different. You would have negative, negative.
Okay.
See, this is what I would do. If I got to that, I would say, okay, 5 pi over 4. I know I'm a 45-degree angle in the third quadrant, right? So how do you get there? You go back 1, so it's negative 1. You go down 1, so that's negative 1. And the hypotenuse is always positive. So if you remember that, think about the ordered pairs that would take you to that point, and then the hypotenuse is always positive. And that'll get it for you. Is that good, Max?
Yeah.
All right. What's your question?
Okay, so like if you had again, like which would you switch for? Does that make sense? Like if you had sine of pi over 4,
Sine of pi over 4?
that would be 45.
That would be the 45 one, and it would be in the first quadrant.
How do you know that's the 45?
Because it's over 4.
The first.
And think about 45 is 1/4 of 180. 30 is 1/6 of 180. So that's the reason 30 degrees is pi over 6.
And the first and second are positive, and the third and fourth are negative, right?
Okay.
Quadrants.
All are positive.
Oh, yeah.
Sine, tangent, cosine. Yes, Olivia, I'm sorry. You've had your hand up for a while.
Okay, you said that looking at that triangle, that the sine would be 1 over pi over 2?
1 over the square root of 2,
Yeah, 1 over the square root of 2.
which would rationalize to become the square root of 2 out of 2.
Yeah, I was going to ask, so we're going to have to rationalize when we
Are we going to have to rationalize? No, you don't have to rationalize, but the arithmetic will be a lot easier. Yes.
Okay, I just can't remember, like, when it's the all sine
In the second quadrant?
Yes.
Yes, only the sign is positive there. Any other questions? All right, on the board last time, we had our notes, and I think you have all this copied down. What is increasing in concave down, increasing in concave up, decreasing in concave down, decreasing in concave up, and I have my artistic renderings of those. Now, for concavity, we've got to check the second derivative. And we will essentially work concavity the same way that we work increasing and decreasing. In increasing and decreasing, we took the first derivative. And after we took the first derivative, what did we do? Set it equal to 0. We set the first derivative equal to 0. After we set the first derivative equal to 0, we solve for x, or t, or whatever the variable was, right? Now, once we did that, what did we do with those values? And we called those values critical numbers.
Put on the number line.
We put them on the number line, right? Okay, when we put them on the number line, what did we do with that bit of information?
Put values around
Whether it was
And plug those values in where?
to the original first derivative.
To the original first derivative. Yes,
Yeah.
we plugged it into the first derivative. And that told us whether it was
Increasing or decreasing.
very good. Increasing or decreasing. Everybody good with that?
Yes.